Hi, and welcome to this edition of Ask AIM, presented by AIM Solder. We want to bring our support and expertise to you, the customer. Today, I have Jen Fijalkowski, Technical Marketing Engineer, to answer questions on the topic of high reliability applications. Hey, Jen.
Hi, Tim.
Jen, how would you describe high reliability application, and what are the shortcomings of existing materials? And ideally, what characteristics would a high reliability solder alloy incorporate?
Well, high reliability materials are required in harsh environments that include cycling, high operating temperature, and high mechanical stress. For example, when SAG-305 is exposed to temperatures above 100 degrees Celsius, the alloy grain structure coarsens, reducing the mechanical properties by as much as 50% compared to before thermocycling. When we think of mechanical stresses, it's easy to imagine something being pulled or twisted. But another source of mechanical stress is the expansion and contraction of the substrates and components as they heat up and cool down or thermally cycle. So all of those expansion and contraction cycles strain the interconnect material, which happens to be the solder. As components shrink and become more powerful, heat is a byproduct. And this then becomes a more profound concern. An example is the LED lighting market. High power LEDs are continuing to miniaturize while the junction temperature between the LED and the substrate can be 100 degrees Celsius or more, potentially cycling hundreds of times per day. Given their material properties, standard SAG-305 alloys are at risk of premature failure in high reliability applications.
So if common alloys are at risk for premature failure, do alternative alloys exist that are more appropriate for high reliability applications?
Yes, AIM's REL22 has been designed to overcome this issue. REL22 is formulated specifically to avoid the grain structure coarsening, which weakens the solder joint so it doesn't lose mechanical strength over time. REL22 studies have shown to more than double the service life in a high thermal cycling environment. On the process side, REL22 is a drop-in for SAG-305 in most applications. You don't have to change equipment, you don't have to change aperture designs, and it can be evaluated easily in solder paste format. REL22 offers better reliability at a slightly lower melting temperature and similar process characteristics compared to SAG-305. So yes, an alternative alloy exists that is convenient to test, convenient to implement, and offers significant advantage in reliability versus traditional SAG-305.
Okay, so in addition to using the right alloy, what else must be considered in high reliability applications?
So if reliability is the main goal, all materials, in addition to the alloy, must be taken into consideration. An assembly is only as reliable as the weakest link, right? So when using a high reliability alloy, such as REL22, there are additional advantages to using alternative surface finishes. So if you're using an OSP surface finish, for example, there may be additional benefits to switching to an ENIG surface finish. Studies show that soldering to ENIG as opposed to bare copper results in higher survivability. So even if the soldering alloy is very strong, you want to make sure you pair it with a material that maximizes the alloy's benefits. There are additional benefits to implementing high reliability solder alloys, such as lowering voiding on BTC style components when using REL22. There are some differences in solder joint appearance that do need to be learned when switching from SAG-305, but there are so many SAG-305 variants in use currently that it's a minor accommodation. So there are a few considerations that need to be made in high reliability applications.
That's very interesting. Thanks, Jen, for sharing your expertise on high reliability applications and introducing AIM's REL22 to our audience. If you have any interest in learning more about alternative alloys like REL22, head on over to aimsolder.com where you can reference AIM's technical articles, connect with AIM's tech and sales support. Until the next episode of Ask AIM, thanks for tuning in.